Sup nerds, we're about to get absolutely lit, Matt.
What are you talking to me?
Hi everybody, welcome back to the channel. I am your host, VirtuaLilly, and today we're going to be talking about lighting in Unity and how it can make and break your game's visual appeal. And in this video, we're going to be delving into how Unity, as well as various other applications, can give you so much more life to your models. So, in Unity, lights are game objects that cast and influence the rendering of light in the game environment. They can create mood, reveal and hide elements, as well as guide your player through your game world. There are four main types of lights in Unity: directional, point, spot, and area. So, directional lights represent sunlight and cast parallel light rays from a singular source. So if you're looking for daytime and large areas, this is probably your go-to lighting source. Point lights are very similar to bulbs, emitting light in all directions from a spherical projection. Spotlights emit light in a cone shape, and they're really good for flashlights, headlights, as well as sconces and various sort of detail lighting that you would like in your world. And then finally, we have area lights. Now, these particular types I don't use, as I use materials to do the exact same thing. However, they are only available for baked lighting and simulate soft, diffuse light sources. So if you're looking for a little bit of light to emit from behind an object, your area light is likely where you're going to be going. So once we figured out the types of light that you want, we want to be figuring out whether you would like this baked or real-time. Now, Unity offers both real-time and baked lighting. Real-time lighting is dynamic and changes instantly, but it can be performance heavy. So this is perfect for flashlights and torches, for things that you would like to light up with the player, controlling those objects. Or if you would like dynamic shadows and casting that is very realistic, then real-time lighting is where you're going to go. However, this will be very CPU intensive. CPU or GPU? Either one, it's going to hurt your computer. But typically, real-time, especially for virtual reality, you're rendering 3 times the amount. So real-time lights can be really performance heavy, especially in virtual reality. So this is where you're probably going to hear the term baked lighting. Now, what is baked lighting? Baked lighting is essentially pre-computed, and it is saved into light maps as a texture. This reduces dramatically the demand on your CPU and your GPU during gameplay. So for baked lighting to happen, you're going to need light maps. Thankfully, Unity can pretty reliably calculate for you light maps if you make sure to click Generate Light Maps button right about here. And what this will do, this will try to pre-compute for you how Unity thinks light is going to affect the game object and how it unpeels a UV of sorts to generate a texture that can influence the lighting in the world. Light mapping is the process of pre-calculating the brightness of surfaces in your game, and this can greatly improve your performance, especially for scenes with very complex lighting. In particular, for my own light maps, I use a tool called Bakery GPU Lightmapper, which is available on the Unity Asset Store. It is an incredibly powerful tool that utilizes your GPU over your CPU for light baking, allowing for highly detailed results in the fraction of the time. Also, Bakery does support shaders that allow mono SH lighting, and this is particularly important for my own styles of lighting, which I've been using consistently for the past year. And no, this is not an ad, however, this is something I do consistently use. Bakery does go on sale very, very frequently, so I highly recommend if you're getting into world building, you're going to need Bakery GPU Lightmapper. Whether you are using the built-in Unity tools or Bakery, either way, the tools are going to generate a form of texture, such as a light map, which essentially kind of applies a secondary texture across the entirety of all your models based on the calculation of lighting generated in the light mapping stage. In full honesty, I don't really know how all this works internally. I press the button, it does a thing, it makes things look pretty. It's essentially it. But in particular for my VRChat worlds, I'm always going to use baked lighting. So that way, everybody has as maximum frames as possible and we can all enjoy a good time. Now, when you get into your light bake, you are going to be flooded with a lot of settings and a lot of terminology which may or may not make sense. So let's have a quick rundown of some of the settings that we will be using. So with these settings, resolution defines the detail level of the light maps. Samples determine the amount of rays sent out from a specific light source, affecting the noise and accuracy of the bake. Bounces set the number of times that light ray will bounce around the scene, influencing indirect lighting. This is where you want the small glows of your area lights or your emissives to slowly bleed a little bit more out than it would originally intend so. And then we have the famous texel count. This helps manage the quality and the size of your baked lighting data. Typically for my own resolutions, I always bake between 512 and 4K textures. For my sample rates, between 16 to 32, and my texel counts will always bounce between 20 to 40 depending on how high a quality I would like my world to be. Increasing the texels, the samples, or the resolution can help remove what we call stains from light baking, where the light mapping isn't quite as precise and leaves small little white splotches in some of your light maps. This can also be a case of how the light mapping was generated in Unity. So this is where you would like to go into your models in Blender or your 3D modeling software, and you can pre-generate your own light maps before Unity. Just make sure to untick this box when you get to that part. However, Unity is pretty consistent in getting a good light mapping, so I very rarely have to generate my own light maps in Blender. Baked lighting is incredibly powerful as it can also take into account the emissive lights generated from materials. Materials play a big role in how lighting behaves in your scene. The properties of a material can greatly influence how it reflects and absorbs light. For example, a material with high smoothness will reflect light sharply, like a mirror, while a rough material will scatter that light, creating a diffuse reflection. Then there is also baked emissive materials, which we mentioned a little bit earlier in our previous video. These materials emit their own light, contributing to the overall lighting in the scene. By baking these into your light maps, you can create glowing surfaces that illuminate their surroundings, whether it be neon sign, a computer screen, or magical runes. However, there will be one final and very annoying, tedious task to do with your light baking. And this is the art of light probes. Now, light probes is a fine art, and it is a case of messing around and finding out. However, light probes essentially are a clever tool in Unity that allows baked lighting data to affect dynamic objects. By strategically placing these in your scene, dynamic objects can pick up indirect lighting and become integrated seamlessly with your pre-calculated lighting. So if you would like the players to be lit in certain ways and have the baked lighting affect them dynamically, you're going to need light probes. The more dense your light probes are, the more dynamic and constantly changing the baked lighting data will affect your dynamic objects. This can increase memory size, so do be careful with the amount placed. However, placing these in strategic places, you can get a soft glow from any area, or if you would like an emissive strip to affect a dynamic object, or if you're also just making sure that all the right colors and the right lighting is hitting all your dynamics properly with your baked data, your light probes are going to be the most important aspect of your tasks. This is going to take a very long time, however. There are some tools out there that can do this for you. However, again, that's all a bunch of settings which I myself am still a little bit struggling. So when I find those out, keep an eye on my socials and I'll try and keep those updated for you. However, essentially, you want to be working in rules of 3 with your light probes. Typically, I place one of these right on the floor, just like an inch or so right above, one at around hip height, and then a third, typically about half a body above head height for your dynamic objects or your players. However, placing a light probe near your glowy areas as well will also bleed and drag that lighting into your dynamic objects as well. Let's play with this example to demonstrate. Here I have placed a light probe in the dark, I have placed a light probe in the light, and then again in the dark. If I move a dynamic object from the dark to the light area to the dark again, this object will be dynamically affected from the light bake without having a real-time light do so. This dramatically helps optimize all of your worlds and make sure that everybody can have some good, decent frames. However, having a real-time light every now and then can be really good, especially for your horror maps. You're definitely gonna need that flashlight. So once we've set all of our light probes and all of our lights up, we're ready for baking. Once we've done our final bake, we also want to make sure that our reflection probes are also taken into account. What is a reflection probe? So in Unity, reflection probes are tools used to simulate the way light interacts and reflects off of surfaces in the environment, creating a more realistic and immersive visual experience. These probes capture a 360-degree view of the surroundings and store it as a cube map, which objects can then use to reflect the environment. You can also adjust the resolution on these, especially for your memory. When we talk about baked reflection probes, it means that these reflections are pre-computed or baked into the scene, rather than being calculated in real time. By baking them, Unity can optimize performance, especially important in complex scenes or on platforms where real-time calculations would be just too resource intensive, i.e. VR. Baked reflection probes are static, meaning they don't adjust the dynamic changes in the scene. They're most appropriate for objects and environments that remain largely unchanged. If the scene undergoes significant changes, such as moving large objects or altering lighting conditions, you need to rebake the reflection probes to update the reflections. Reflection probes are incredibly important, especially for your normals and your reflective textures in your materials. So if your scene is looking a little bit dull and lifeless, you may need to just double check that your reflection probes are baked. If you're using the Bakery GPU Lightmapper, there is a button specifically for that, so make sure to hit that. Another thing you can also hit is the like and subscribe button to help this channel grow. This VTuber is in need of a lot more friends, so please bring them all over and hopefully we can learn a little bit more about the world we build around us. All right, and don't forget, next time we're going to be talking... We're good? Sorry, just a little hole in the chair. Anyway, and next time we're going to be talking about models and how I use Blender a little bit. So don't forget to make sure that notification bell is on for those updates. And make sure to always have a look at our demo videos as well, where I give a quick demonstration on how to do certain types of world building, either using Booth, Gumroad, Unity, Blender, any assets you can find, we can make it happen. So... take care. Toodaloos. Now I'm actually gonna go lit. Come on. It's really funny because my eye sockets are right here. Like right at this point. Right here, y'all. That's where my eye is. Like this is one thing about sitting down in VR. It's just you kind of like mess your head up a little bit. But anyway, big shout out to Kung for updating the IKs and stuff like this for VRChat. Y'all amazing. Anyway.